Audio Jungle.
I'm Charlie Bithala.
And I'm Mark Hobbs.
We're co-founders of Intrinsic Technologies Incorporated and ITI Electromagnetic Products.
We're not actors, we're engineers, and we have some really cool technology to present.
Mark is right. We're excited to present the invention of software-controlled robotic cells for land, sea, and space applications. The cells are patent pending and are called configurable raw materials, CRMs.
The invention of CRMs was inspired by the microbots in the Disney movie Big Hero 6. CRMs are reusable, rechargeable, and reconfigurable, much like the microbots.
Multiple CRMs are software controlled to self-assemble into predefined structures. These structures can be static, such as furniture or bridges, or dynamic, such as bearings or doorways. Here's an animation of structure formation.
CRMs are capable of movement through all terrain types, utilizing a walking function. They're able to construct bridges and walkways out of themselves, similar to army ants traversing the forest floor. Here's an animation of the walking function.
By reconfigurable, we mean that structures can be assembled and utilized until a new structure is desired. The existing structure can then be disassembled and a new structure created from the same CRMs. The assembly and disassembly process are all software controlled.
The patent submission addresses all plutonic solids. However, the CRMs in this campaign are based on the dodecahedron, DOD for short, as shown in the walking animation.
Now we're going to present the concept using various models.
This Kickstarter campaign is being initiated to develop the prototype stage, which would be about the size of a softball, the end product being about the size of these dice, and this is a depiction of how CRMs connect.
This model shows an example of DODs walking, or CRMs walking from one position to the next. First, we would have one CRM connect with the second CRM. Then a third CRM is introduced on this end, so we'd connect to the second. From there, they would proceed to walk from face to face across the two CRMs to their final position, and that completes the translation or walk. This model is a geometric model of the dodecahedron. It was built to show the coordinate systems, the X, Y, and Z axes of the dodecahedron, and also simulate, like it's set up right now, with the magnetics on each side. As Mark will show, if you rotate one, there's interactions between all the other sides, so it gives us what happens in the real world. This assembly right here is a representation of each module on each face of this final CRM. This is considered the magnetic module, which has the magnet. This is a battery module, and this will be the core processor. The core processor sits at the center of this dodecahedron, and on each side of this, the battery module and the magnetic module will attach, forming the final shape of the dodecahedron. This model represents two CRMs, either connecting or disconnecting. I have two magnets in here. One is just rotational, one is translational, and it goes up this shaft. This model will be equipped with a torque transducer on this shaft, an encoder on the back for the angle. Therefore, I can get torque versus angle of the separation of the two magnets. Demonstrating this, there's a magnet right down here. As I turn this, the other translational magnet will rise and fall as it's attracted and repelled. This model represents two sides of two separate CRMs. It consists of an Arduino Uno, two motor drivers, two stepper motors, the associated magnets with those, Hall sensors, and proximity sensors. The proximity sensors are triggered by these two levers here. In this scenario, we're going to represent the sides of the CRM and their functionality. It has four different states. The magnet can be facing with its north pole out, with its south pole out, at an idle position, which is neutral, parallel to the face of the DOD, and a dither mode. Dither is basically when two CRMs connect. If they're misaligned, we can vibrate them to bring them into alignment. Here we'll demonstrate the feedback loop for turning the magnets to their north position. This represents the motors turning to the south position with the feedback loop. This next scenario will represent them going to an idle position where the magnetic poles are parallel to the surface of the face of the Dodd. The last part of this scenario is showing dither. In scenario 2, we show two CRMs connecting. One CRM, this face, the magnet will be facing north. On this CRM, the magnet will be facing south. When they do, the two CRMs will connect. This is two CRMs connecting. We will now put them in the idle position. Now we will rotate one of the CRMs to the north position so it'll accept a connection. The other motor will go to the south position to accept the first CRM, making the connection, which will trigger the prox sensors, and we get a readout with the system saying they're connected. Now the two sides will dither, aligning the two sides of the CRMs. Now motor 2 rotates to north, which will repel the two CRMs, which triggers the prox sensors to say that there's nothing near each other and they're disconnected. In this scenario, what we show is one CRM has an unwanted connection with another CRM and how it dislodges the second CRM to itself. Both motors will go to the idle position to start. Now the prox sensor is sensing two CRMs together, so both motors are rotating, trying to hit a spot so they're kicking each other away from each other. Once the prox sensors show that there is no connection anymore, they will both go for their north pole facing out, so they will repel each other. This model represents 12 sides of the dodecahedron, which we've previously mentioned. So each one of these sides contains this sensor group, which contains the motor, a proximity sensor, and a Hall sensor for monitoring communications with other CRMs. It's run by an Arduino Mega. Mark will demonstrate that we can run the motors on 6 at a time with this setup. It's a development model, and it's gone through multiple iterations. Future development of this model will incorporate a multi-core processor, which will allow us to monitor all the sensors and rotate all the motors independently, giving it much more functionality.
Our business model includes a royalty program that provides public compensation for CRM structure designs.
The program is similar to compensation provided to an architect for a design.
Since CRM structures are additive, one designer can be compensated for a window design, another designer can be compensated for a door design, while yet a third designer can be compensated for a complete habitat design. The royalties to the designers have no expiration.
We've created an application called Vienia for the purpose of creating the CRM structure designs. The application is available for Windows, Mac, Android, and iPhone. The designs are stored on ITI servers and shared amongst the user community.
The application is advertisement free and available for download at no cost. Here's a screenshot of the application.
This is not a myth to be busted, but an opportunity to participate in implementing this new awesome branch of technology.
With your help, we can provide a reusable building material for everyone to design structures for a sustainable planet.
Please see our website for more information regarding CRMs, the royalty program, and the Vienia Dodd Structure Designs application.
Thanks for your consideration. We can be contacted via the webpage.